This question is asking us to find the critical points of the function h of x, which is 2 cosine 2x, where negative pi is less than or equal to x, which is less than or equal to pi. The reason they say that and they specify this domain is because there are infinitely many possibilities because cosine is a periodic function. So it cycles up and down, up and down, up and down. But we're restricted here and we have to think, well, what are critical points? Critical points are where either the derivative doesn't exist of the function or where the derivative equals 0. So the first thing we need to do is we need to find the derivative. So h prime of x is going to be, well, I see I'm going to have to apply the chain rule, but here 2 cosine is going to end up being negative 2 sine because the derivative of cosine is negative sine. So we get negative 2 sine of 2x times the derivative of what was on the inside, and the derivative of 2x is just 2. So I'm going to rewrite this as negative 4 sine of 2x. Alrighty. Now, the question is there any place where the derivative doesn't exist? That's the first thing we want to ask. Does the derivative exist everywhere? Does the derivative exist everywhere? And the answer here is yes. Because sine, there's no reason why sine wouldn't exist. There's nothing in a denominator. You can find the sine of any number, so any x value would work. So, yes. So we don't care about number 1. What about number 2? Is there a place where the derivative equals 0? So let's set that up. Negative 4 sine of 2x equals 0. We divide both sides by negative 4, and we get sine of 2x equals 0. And so now we need to find where on our unit circle does sine equal 0. And if you don't remember the unit circle, I'm going to bring up an example for us to use here. And so here we can see it's a little slanted. We want to see where does sine equal 0. And I see that sine equals 0 at 0, at pi. And I also know that it's going to happen at 2 pi as well. And so I can say 2x equals pi, 2x equals 0, and 2x equals 2 pi. And here we're going to need to divide by 2 for all of them in order to get x by itself. So we get x equals pi half, x equals 0, and x equals pi. Now you might be wondering, what about the negative side? And that's true. Remember, for when we're going negative, I'm going to look back at the unit circle. Instead of rotating counterclockwise, if we're going negative, we're going to be rotating clockwise. And so that means negative pi, I'm going to write that down, negative pi and negative 2 pi also work to give a sine of 0. So I'm going to write those down. 2x equals negative pi, 2x equals negative 2 pi. When I divide there, I get x equals negative pi over 2, and x equals negative pi. And so we see here that there are 5 critical points. X equals pi over 2, x equals 0, x equals pi, x equals negative pi, and x equals negative pi over 2. We could rewrite it, and I'm going to write this in green just so we can be clear as to where I'm writing this. X equals 0, plus or minus pi half, or plus or minus pi. Those are all of the critical points possible.